Our next topic, as we continue to study motion and forces, is going to be looking at action and reaction. So it's now time for us to focus in on Newton's third law of motion. So just a reminder of Newton's third law of motion: when one object exerts a force on a second object, the second object exerts an equal but opposite force on the first. Okay, so opposite but equal, action and reaction. So for these problems, we have action-reaction pairs. So every action has a paired reaction. So for example, a hammer and a nail. The hammer exerts a force on the nail to the right. The nail exerts an equal but opposite force on the hammer to the left. Another example is rockets. The rocket exerts a downward force on the exhaust gases. The gases exert an equal but opposite upward force on the rocket. Both objects in these action-reaction pairs accelerate. The amount of acceleration depends on the mass of the object. So something with a small mass will have more acceleration. Something with a large mass will have less acceleration. And this allows us to calculate momentum. So momentum is a quantity of motion that is derived by multiplying the mass times the velocity. So here's your momentum equation. Go ahead and add this to your equation sheet. Here, P equals momentum. Kilograms meters per second is your unit. M, as it always has, stands for mass. That needs to be measured in kilograms. So if a problem gives you grams, you need to convert it to kilograms first. And then V, as it always has, stands for velocity, which is meters per second. Okay? And here's our triangle for this equation. Since P equals M times V, the M and the V go on the bottom because side by side means multiply. And so then if you need to solve for M, you would do P divided by V. If you need to solve for V, you would do P divided by M. If you need to solve for P, it's M times V. Okay, so here's our nice triangle for us. Go ahead and add that to your equation sheet too. All right, let's do some example problems. Find the momentum of a bumper car if it has a total mass of 280 kilograms and a velocity of 3.2 meters per second. All right, so analyze the problem. What do we know? What do we need to know? My momentum is unknown. Find the momentum. So find P. If it has a total mass of 280 kilograms, so I have my mass, and a velocity of 3.2 meters per second. Okay, so here's my information, my known and unknowns. So let's look. I have a P, an M, and a V. What kind of equation do I have on my equation sheet with a P, an M, and a V? And I see that that's my momentum equation. So here's my triangle. All right, my P is my unknown, so my triangle tells me then, if I cover that up, that I have to do M times V. Okay, so there's my equation. Plug in those numbers, and then do the math. Okay, 280 times 3.2 is 896. None of my units here cancel off because I'm multiplying, so I keep all my units, so it is kilograms meters per second. Okay, and that is always the unit we want with momentum, so keep that in mind for your units, because remember, we always have to have a number and a unit in order to get our credit. Okay, the momentum of a second bumper car is 675 kilograms meters per second. What is its velocity if its total mass is 300 kilograms. So let's analyze the problem. What do we know? What do we need to know? The momentum of a second bumper car is 675. So I know my momentum, I know my P. What is its velocity? Okay, so my velocity is my unknown if its total mass is 300 kilograms. Okay, so there's my known and my unknown. Got my equation for momentum. Cover up the V because that's what I don't know. And my triangle tells me that I need to do momentum divided by mass. Thank you, triangle. And then I just plug in my numbers. So my momentum is 675. My mass is 300. Okay, I'm doing kilograms divided by kilograms. So those are going to cancel off. I'm going to be left with just my meters per second. Okay, and I just pop into my calculator, 675 divided by 300. And I get 2.25 meters per second, number and unit. All right, if you need help with this, if you don't understand how to get these answers, if you did not get the same answers while you were calculating along with me, please get into contact with me so I can help you out, because now it's time for some momentum independent practice.